interconnection, and where we studied this topic in our first unit. If I consider data link layer, it comes between network layer as well as physical layer. By using this mechanism, I can able to check only single bit error. Hello to all, a warm welcome to my new unit, and the unit name here is the data link layer. I'm your Revati ma'am, faculty from the Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So dear student, in this unit, I'm going to discuss data link layer and the different kinds of issue comes under this data link layer. Now the question is, what is data link layer and where we studied this data link layer? So dear student, in my unit 1, I have discussed what is data link layer. So in our OSI reference model, the second layer is data link layer. And in data link layer, the datas are called frames. Now, let me to start with data link layer. So, data link layer is the second layer of open system interconnection, and where we studied this topic in our first unit. And if I consider OSI reference model, it includes 7 layers. In that, the second layer is data link layer. And this link layer is responsible for node to node communication or connection. So what is node here? That is nothing but the two system or two computer device or two entity, and data link layer is responsible for node to node communication, and it's also responsible for encoding and decoding. So what is encoding? That is nothing but the encrypting, and whatever decoding, that is nothing but the decryption. So what is the job of the data link layer? Is to provide the security for our data. To provide the security for our data, it provides encoding and decoding. Now, this is considered the most complex layer of the OSI reference model, because here this layer is responsible for providing the node-to-node connection as well as it provides data encoding and data decoding. Now, to design data link layer, it's a tedious task or it is a complex task because it provides certain issue. Let me to discuss some of the design issue here. So here, service provided to the network layer. So dear student, if I consider data link layer, what is my first design issue? That is service provided to the network layer. So dear student, if I consider OSI reference model, I'm going to have 7 different layers. That is application layer, presentation layer, session layer, transportation layer, network layer, data link layer, and physical layer. And if I consider sender side, I'm going to start from the application layer, then presentation, session, transportation, network, data link layer, and physical layer. And if I consider receiver side, I'm going to start from the bottom. So I'm going to have the physical layer, then data link layer, network layer, and so on. Now, if I consider data link layer, it comes between network layer as well as physical layer. Now, service provided to the network layer is very difficult, because if I consider from the bottom, okay, I'm going to have the data link layer, then this layer provides the services to the network layer. So it is a tedious task or difficult task. The data link layer act as a service interface. So this data layer is going to act like a service interface to the network layer. The principal services is transferring the data from network layer on sending machine. So what is the main principal service this data link layer must provide? There's nothing but the data transferring. So here, what is the meaning of network? There is nothing but the transferring the data from one node to another. At the same time, receive the data from one node to another. So transferring the data from one layer to another layer is also one of the tedious tasks. And another one is frame synchronization. So what is frame synchronization? So dear student, just remember that in data link layer, whatever the data we have, that is called frames. And I cannot able to send whole data together. So what I'm going to do? I'm going to break the data into smaller piece. For example, think that I have 10 GB of data. I cannot able to send this 10 GB of data together. So what I'm going to do? I'm going to break this data into 10 different 1 GB data, and that is itself known as frames in data link layer. And when I send the frames one by one, there must be a synchronization between sender side and receiver side. That is known as frame synchronization. So for each frame, I'm going to specify unique number that's known as frame number. So the starting and ending of each frame should be identified so that the frame can be recognized by the destination machine. So to identify the frames uniquely, what I'm going to do? I'm going to assign the frame number. The another issue here is flow control. So what is flow control? Suppose think that I'm going to send the data one after another continuously. Now what's going to happen? I'm going to met congestion. There's nothing but the traffic. Okay, now what I want to do? I want to send the data one by one. Okay, there must be a agreement between sender and receiver. For example, think that I have sender A and I have sender B. So here I have sender A and receiver B. Now sender is going to send the data to B. Okay, now B is responsible for receiving the data or packet. Now send the acknowledgement back to the A. Now A understands that B received the frame 1. Now I want to send the frame 2. Now A is going to send the frame 2. Now B is going to receive frame 2 and send the acknowledgement back to the sender A, and this process itself known as flow control. Okay, so flow control is done to prevent the flow of the data frame at the receiver end. The source machine must not share the data frame at a rate faster than the capacity of destination machine. So dear student, whenever I want to send any frame to receiver, okay, there must be an agreement between sender side as well as receiver side. In the sense, both the machine must have the same configuration, same data rate, same data access rate. Okay, then only I can able to send the data frequently or simultaneously. Then error control. So what is error control? During the transmission of data, the data bit may corrupted or the data bit may get changed. Now I want to identify which bit is corrupted and how to correct that bit. So that is known as error control. So error control is done by prevent duplication of frames. So how the error control is done? By preventing duplicate frames. So what is duplicate frame? Replication of the same frame or replica. Okay, now the job of the data link layer is to avoid duplicate frames. And how we are going to avoid duplicate frame? By assigning frame numbers. So the error introduced during transmission from source to destination machine must be detected and corrected at the destination machine. So whatever the data it is corrupted, that is identified by the destination machine. So here what is destination machine? There is nothing but the receiver, and that must be corrected. Okay, so dear student, in my today's class, I started with design issues of data link layer. What are the design issue? That is related to the services provided to the network layer. And we also discussed flow controls, then frame synchronization as well as error detection. Now, let me discuss error detection in detail. So, what is error detection? Before that, think that I have the data 1 0 0 0 1 1 0 and 0. So what is the length of the data here? It is 8 bit. It is 8 bit. Okay. Now I'm going to send this data to destination machine. In the destination machine, I'm going to receive 1 0 0 1 1 1 0 0. See here. Here I have 3 zeros, but here I have only 2 0. Okay, now this 0 is changed to 1. It is going to happen because of noise. Okay, so the data bit may get corrupted or changed from 0 to 1 or 1 to 0. And this is known as error. Okay, this is known as error. Now, what is the need of error detection? It's mainly used to detect the error and identify. Detection in the sense what? Identifying the error and correct the error. So here, which bit is get corrupted? That is the 4th bit. So 4th bit is get corrupted. Now I want to identify which bit is corrupted and how to recover that bit. So here error detection. During the transmission of data, the data bit may get corrupted and that is known as errors. Okay, now I want to identify what kind of error, either single bit error or burst error. If I consider this example, only one bit is get corrupted, so it is example for single bit error. And if I consider burst error, see here, this is my data at the sender side and I have the data at the receiver side. So this is the data received by the destination machine. Now see here, first bit is same. And if I consider second bit, see it is 0 and it is 1. Okay, second bit, third bit is same, fourth one is same, and fifth one is get toggled. Toggled in the sense what? Zeros change to 1, 1 change to 0. So it is toggled. Okay, fine. Now see here. So dear student, this is my starting bit and this is my ending bit. And the length between starting and ending bit, that much bits are corrupted here. So what is the length of the bit here? 4. That is 1, 2, 3 and 4. And this kind of errors are known as burst error. See here, more than 2 bits are get corrupted and this is known as burst error. An error is a situation, it's a situation when the message received at the receiver side end is not identical to the message transmitted. See here, I'm going to send this message, okay, but at the receiver side, receiver is going to receive this message. Now check, both the messages are same. No, right? So one bit is get toggled and this situation is known as error. Now to detect the errors, we are going to use three different types or three different mechanisms, that is single bit or single parity checking or even parity or parity. Another one checksum and another one polynomial codes. That's nothing but the cyclic redundancy check. That is CRC. Now dear student, in my today's class, I am just going to deal only my first type, that is single bit checking or single bit parity checking or single parity checking, or it is even parity. So dear student, as the name itself indicates that I am going to check only single bit. Okay, I'm going to have one separate bit called parity bit. I'm going to focus or I'm going to check only that bit. For example, think that I have the data 1, 1, 1, 0, 0, 0 and 0. And I'm going to have the parity bit. So what is the length of the data here? It is only 8 bit. Now, including parity bit, it is 9 bit. So dear student, focus here. See here, how many ones I have? That is 4 ones. 4 is nothing but the even number. And how many zeros? 4 zeros, even number. Okay, but here I want to consider only ones. Okay, how many ones? 4 ones, it's even number. So if I have even number of ones, in my parity bit, I am going to place 0. Even number of ones, in my parity bit, I am going to place 0. Okay, fine. Now, if I am going to have odd number of ones, then what I want to do? I want to place 1 in my parity bit in order to make it is even number of ones. I repeat, if I am going to have only odd number of ones, to make it is even parity, I am going to place 1 in my parity bit. So, single bit parity checking is the simple mechanism and inexpensive mechanism. Here I am going to have the parity bit. That parity bit is known as redundant bit. Okay, I am going to have the data. Along with that, I am going to append one parity bit or redundant bit. Based on my ones in my data bit, I am going to add 0 or 1. Okay, fine. So, in this technique, a redundant bit is known as a parity bit, which is appended at the end of the data bit. So, I am going to append at the end of the data bit so that the number of 1 becomes even. So, here my intention is to make the number of 1 is equal to even number of ones. Therefore, the total number of transmitted bit is 9 bit. So, actually, I am going to have 8 bit of data. For that, I am going to add 1 parity bit. Now, the total length of the data here is 9 bit. Okay, fine. Now, if the number of ones bit is odd, okay, fine. See here, 1, 0, 1, 0, 1, 0, 0, 0. Okay, this is my data bit and I'm going to have the parity bit. Fine. Now see here, how many ones I have? 3. So 3 is nothing but the odd number. Now to make it is even parity, what I'm going to do? I'm going to add 1 here. I'm going to add 1 here. Now it is my even parity. For example, I'll take another one. Okay, this is my data bit. Now see, how many ones I have? Total 4 ones. Okay, 4 is nothing but the even number. Okay, 4 ones. In my parity bit, I'm going to place 0. Okay, if odd number of ones in my parity bit, I'm going to place 1 to make it even parity. And if I'm going to have even number of ones in my parity bit, I'm going to place 0. Now let me to consider this diagram. See here, I'm going to have two entity, that is nothing but the sender and receiver. Okay, fine. Here sender is going to have the data. Okay, that is 101111. I'm just going to focus only once. So 1, 2, 3, 4 and 5. 5 ones I have here. Okay. So 5 is nothing but the odd number. To make it even parity, so what I will do? I'm going to place 1 in my parity bit. See, I'm going to place 1 in my parity bit and I'm going to send the data through the transmission media. So what is transmission media? I can have physical or wireless transmission media. And at the receiver side, I'm going to receive the data. Once again, I'm going to compute the parity bit. 1, 2, 3, 4, 5 and 6. So what is the length of ones here? It is 6. I have 6 ones. I have 6 ones. 6 is nothing but the even number. Okay, so here I'm going to check if I'm going to have even number of ones in my received data, then what I want to do? I want to accept the data. So what's the meaning? The data bits are not corrupted. So I'm going to accept the data. If any one bit is get changed, then what's the meaning? The data bits are corrupted. So what I'm going to do? I'm going to reject the data. So here, by using this method, I can able to correct only a single bit error. Single bit error in the sense what? Only one bit I can able to identify and I can able to correct. So dear student, from the examination point of view, the single parity check, single bit parity check is very, very important and it's also called by the name even parity or it's just a parity. How to remember the concept here? I want to consider total number of ones in my data bit. If I'm going to have even number of ones, directly place 0 in my parity bit. Suppose if I have odd number of ones, then write 1 in my parity bit in order to make it even parity. Now, let me to see the disadvantage of this single parity checking. By using this mechanism, I can able to check only single bit error and which is going to happen very rarely. And if 2 or more bits are corrupted, then this method is unused or it is not used to identify 2 or more bit which is corrupted during the transmission of data. So we can able to use this method only for single bit error. If I am going to have the burst error, then I cannot able to use single parity check. Anyway, dear student, in my today's class, I started with what is data linked layer and what are the different kinds of design issue we are going to face while designing data linked layer. Along with that, I have discussed error detection. In that, I have discussed single parity bit or single parity checking. Anyway, dear student, in my next session, I'm going to discuss one more error detection technique, that is checksum. Until that, keep watching and keep learning. Thank you.